Okay, let's dive into one of the first truly weird rules we all learn in math. A negative times a negative equals a positive. It just feels wrong, doesn't it? It's one of those rules we're often told to just memorize, but today we're actually going to figure out why it has to be true.
You know, the poet Ogden Nash had this great line that kind of nails how this rule usually gets taught. It's just presented as this weird fact, a piece of mathematical magic, and we're told, hey, don't worry about the why, just accept it and let's move on.
Well, with all due respect to Mr. Nash, we are absolutely going to discuss it, because digging into that why is where things get really, really interesting.
And let's start by just saying, if you've ever thought this rule was kind of strange or absurd, you are in very, very good company.
That's the famous French writer Stendhal, all the way back in the 19th century, having the exact same frustration we do. Historically, even brilliant mathematicians originally described negative numbers as absurd and nonsensical. So this isn't some new confusion, it's a deep one.
And that old school struggle, yeah, it often shows up right in our classrooms. We ask our teacher why, and the answer we get is some version of, well, that's just the rule. Today, we're going to get a much better answer.
So where do we start? Well, before we jump into the really formal math, let's try to make this whole thing feel right. We're going to use some simple, real-world examples to build up our intuition.
All right, first up, money. This is usually a pretty easy one to grasp. Just think of cash that you have as a positive and a debt, an IOU, as a negative. And we'll say that giving something is a positive action while taking away something is a negative action. Make sense, right? Okay, now let's zero in on that very last row. Imagine someone takes from you, that's a negative action, 3 of your $10 debts, which are a negative value. So what just happened to you? Well, having someone take away your debt is a good thing. You are now $30 richer. A negative action applied to a negative thing resulted in a positive outcome for you. Okay, if the money thing didn't quite click, no worries. Let's try thinking about it with movement. Picture yourself standing on a long number line. The first number in a multiplication problem tells you which way to face. Positive means you face forward, negative means you face backward. The second number tells you how to move. Positive means walk forward, negative means walk backward. Let's actually walk through this. A positive times a positive? Simple. Face forward and walk forward. You move in the positive direction. But follow that logic all the way down to the last step. Negative times negative. This time, you face backward, towards all the negative numbers. But then, you also walk backward. And what happens when you walk backward while you're facing backward? You actually move forward, into positive territory. See, the two negatives just cancel each other out. You know, we do this with language all the time and don't even think twice about it. A double negative makes a positive. If I tell you, do not eat, what am I really saying? I'm saying eat. It's just an intuitive way our brains already get this logic. Okay, so the analogies are cool. They help it feel right. But what does the math itself have to say? Well, it turns out this rule isn't just some helpful idea we made up. It's an inevitable conclusion if you want math to be consistent. Let me show you what I mean by looking at a simple pattern.
We're going to start with something super familiar, a basic multiplication table. Everyone knows this. Everything's positive. Everything's predictable. Absolutely no surprises here. But now, let's stretch this table out a little bit, to the left, past 0. Just look at that row for 3. As we move from right to left, the answers go down by 3 each time. We go from 9 to 6 to 3 to 0. So for that pattern to continue, what does the next number have to be? It has to be -3. This shows perfectly why a positive times a negative has to be negative. So what happens when we go one step further and continue the pattern with a negative row? Let's look at the row for -2. Moving from right to left, the values are actually increasing by 2. We go from -4 to -2 to 0. So to keep this perfectly logical pattern going, what has to come next? It has to be +2 and then +4. There is literally no other choice. For the simple, beautiful logic of a multiplication table to hold together, a negative times a negative must be positive. So the pattern is pretty convincing, right? But for a mathematician, even that isn't quite enough. We need to show that any other answer would literally cause the entire system of math to just break.
I mean, is it possible that these cool analogies and nice-looking patterns are just a big coincidence? A clever trick? To be absolutely 100% sure, we need to prove it. And for that, we only need one fundamental rule that we can all agree on. And that rule is the distributive property. It's a cornerstone of algebra. All it says is that A times the quantity B plus C is the exact same thing as A times B plus A times C. And all we're going to do is say, okay, this rule works for positive numbers, so it has to work when negatives are involved too.
All right, stick with me here. We're going to walk through this chain of logic, step by step. First, we start with a fact everyone agrees on. Anything times 0 is 0. So -5 times 0 has to be 0. Okay. Second, let's get a little creative. We can rewrite that 0 as 3 plus -3. So our equation becomes -5 times the quantity 3 plus -3 equals 0. Third, now we use our one and only rule, the distributive property. This means we get -5 times 3 plus -5 times -3, and all of that still has to equal 0. Fourth, let's solve the easy part. We already know from our pattern that -5 times +3 is -15. And fifth, this is the crucial moment. Look what we have. -15 plus a something equals 0. What is that something? What is the one and only number in the universe that you can add to -15 to get to 0? It has to be +15. There is no other answer.
And that's where we get this sort of Sherlock Holmes moment. We've just proven that for the rules of math to not break, -5 times -3 must equal +15. Any other answer is impossible. So even though it might feel weird, it has to be the truth.
So, as we wrap this all up, you can see there are really two main paths to get your head around this strange little rule. On the one hand, you have the intuitive models, things like money and walking on a number line, that help us visualize the idea and make it feel more natural. And on the other hand, you've got the formal proof, the pure logic, that shows why the rule must be true just to keep math from falling apart. Both paths lead to the same destination.
And this whole idea, this tension between needing things we can picture and needing abstract rules that are logically consistent, that's not just about negative numbers. It's at the very heart of how we learn and make sense of all kinds of complex ideas in math.
Which really leaves us with one last kind of mind-bending question. The fact that logic forces this rule on us makes you wonder, did we humans just invent math with a bunch of rules that we designed to be consistent? Or is math a fundamental truth of the universe, and we are just slowly discovering its rules, no matter how strange they might seem at first? Something to think about. Thanks for joining me.